beginning with oh he was beginning with systems design and finite element analysis. So as he pointed out, it was nothing related to microscopy. But since 2006, he's been working with a sister at their company, Quimica Tech in Chihuahua, Mexico, where he specializes in microscopy and often says his job is about playing with microscopes and teaching others how to get the most out of theirs, which I think is what he'll be doing today. And he also manages their social media, including Instagram at Quimica_tech. So if you want to see more of his images, you can go there. So he's been honored by institutions such as the Microscopy Society of America, the Royal Microscopical Society, Optica. Actually, I'm not going to go through all of them, but he's won lots of awards for his micro photographs. And some of them have been displayed in museums as well, including the Science and Industry Museum in Manchester and various galleries in Lausanne, Zurich, and Bristol. He loves sharing his knowledge and expertise globally. He conducts talks and microscopy courses in Mexico, the USA, Germany, and India. And in 2019, he was granted a patent in Mexico, the USA, and Germany for a device that enables the observation of silicon wafers and their connections within LED capsules. He's also a man after my own heart. Once he gets out of the lab, he enjoys lots of outdoor hobbies. During his college days, he practiced pole vaulting and decathlon as part of the Mexican national team. That's very impressive. And now during weekends, he heads off to the Chihuahua Desert on his adventure bike, searching for rock climbing fun. But today, I think we're not going to hear so much about rock climbing, more about pretty microscope images. So please take it away, Manuel.
Thank you so much, Alison, for such a wonderful introduction. And I will start sharing my screen. Let me click these buttons and let me find the button to share screen and share. And please let me know if you can see it. Excellent. Well, thank you so much. I'm very happy you're having me here today for this talk about microscopy and art, and I want to thank BINA and all staff and members for the opportunity. It's really a honor for me to have this opportunity because I enjoy a lot talking about microscopy. And well, today, before start, let me see. Yeah. Before start, I want to make clear that this presentation is not about to teach you how to do art or science with microscopes. I have no idea what art is. I don't consider myself an artist. I just take photos when I see something that I like. And I'm definitely not a scientist. I'm too rebel and messy to follow protocols and rules in the labs. So I cannot teach you how to do science. So this presentation is more an invitation to you to consider the symbiosis between science and art, or in our case, microscopy and art, in order to have an extra tool to improve the communication of science. And well, I want to start with these questions. How are scientists evaluated? And yeah, there are several metrics we can use to evaluate our scientists, but I want to focus in one, and it is the number of papers you publish and the number of the citation this paper received. So usually the more papers you publish, the better, the more citation, the better, and that's turned out most of the time, or usually in more money, so that's more funds, better labs, more students, and in general, more prestige. But scientists have to pay to journals in order to get published. And there is that story, at least in Mexico, many Mexican scientists have to pay with their own money from their own pocket in order to get published. But if you include like eye-catching images in your research, in your paper, you may have another opportunities to tell the world what you are doing in your lab. And these opportunities there are some magazines that are not journals per se, but they are pretty well related with science. And these journals are, these magazines are looking for images to publish. And And here, you may not be able to publish your entire paper, but at least for sure you can publish the abstract. And you can always tell the people, okay, if you want to know more about this topic, you can go to my webpage, or you can download my paper from this link. And also the good thing is that you can get money from this publication. So this magazine usually give you something in between $100 to $500 for the images. So yeah, it's not that much, but for sure you can buy some beers with those bucks. So in science, and especially microscopy, a good image is that one that give you information or that give you data that you can analyze. Those are the good images. But the great images not only provide information, but also are eye-catching. They grab the attention of people. And sometimes I receive comments in social media, in Instagram. By the way, you are very welcome to follow Química Tech in Instagram. It's Química_Tech, where I post images that I take with the microscope. And I received comments like they're telling me, okay, your image is beautiful, but it's not useful for science. So there is no data, no information I can analyze in that image. But I will say, I mean, I'm not feel offended by that. It's just a fact that, yeah, probably the image don't give you information, but it's not totally useless. And I will have this example. This is from material science. It's a shape memory alloy observed in bright field and also in circular polarized light. And well, this shape memory alloy, this kind of material that you can bend and deform, and then if you apply a little bit of heat, this material will recover its initial shape. That's why the name shape memory alloy. And material scientists and materials engineers, they run a analysis that is called a grain size analysis. So they measure the size of the grains in the material. And let me point it here. These dark lines here are the grain boundaries. So the size of the grains have a big influence in the mechanical properties of the materials. So this analysis, the grain size analysis, run in bright field. However, the circular polarized light image has a bunch of colors in contrast and make the image a little bit more attractive, but yeah, it is useless for the grain size analysis. However, last year I received an invitation and they invited me to submit some images to a material science journal, and I sent a photo from this same sample, not this one, but it came from the same sample. And at the beginning of this year, I received an email from the editors of this journal, and they told me, okay, we want to publish your photo, but please share with us a little bit more information. They wanted to know what is the material. Well, it was shape memory alloy, but they wanted to know its composition, how this sample was made, how was the sample preparation, what is the purpose of this material, what is the purpose of this research. And they were kind of surprised when I told them that I cannot answer most of those questions because I found this sample almost in the garbage. Like, and I only know this is a shape memory alloy because there was a label on the sample. And in Chihuahua City is a city like 400 kilometers from where I live. There is located the Research Center for Advanced Material, the CIMAP, and they produce such a huge amount of samples that they do not have a space to store them. So they throw it away, they pay for the disposal, but they are very kind to let me go into this disposal bin and grab samples that are not wanted anymore. So I told this to the editors and they were like, okay, we are going to publish it anyway, but instead of put it in the like a technical section, we are going to put it in the art section. And this opportunity came just because someone found this image beautiful, not because my name, not because my institution, no, it's only because someone found this beautiful. And yeah, beauty is something very subjective. It will depend on your background, your culture, your personal preferences. So it's not the same for everyone. But the good thing is that if we can find it beauty everywhere, and if you are a microscopist, you may know that a slide of 25 by 75 millimeters has a bunch of opportunities to give you something beautiful. And science itself is beautiful. So we have to work to make this beauty available not only for our peers or our colleagues, but to everybody, especially for those one who are not science people, or those persons who are not related with science. And with microscopy, we have a good chance because, well, microscopy, photography, painting, illustration, all these have in common that they generate images. And photography and painting are pretty well known as artistic expression too. And with microscopy, we can create also art. But we have an advantage in microscopy because we observe things at such a small scale that what we observe turns abstract. For a scientific science material engineer, this image could they identify immediately still as microstructures. But for me, these are just black and white lines. So this abstraction gives you the opportunity to reach people that will not read your scientific paper, will not attend your scientific presentation in a congress, will not read your poster. So we can increase the outreach of the science you are doing by including this, or by taking advantage of this abstraction of the images. And also we have to take advantage of this symbiosis between science and art, or in your case, between microscopy and art. And there are two sentences that I really like. And these are, science can be inspired by art, and art can be driven by science. And to explain a little bit more this, let me tell you a couple of stories. This image of crystals of amino acids in polarized light, I took it in 2022. And then in 2023, I was invited by the Biocommunication Association, the BCA, to give a conference in Santa Fe, New Mexico, to explain how I took this photo. And well, this Bioimaging Communication is a wonderful organization, just like BINA and LAVI and GBI. In Biocommunication Association, you can find a wonderful group of people always willing to challenge you in a good way, but at the same time, they're helping you to sharing knowledge to help you to improve your photography skills. But anyway, in these conferences in Santa Fe, there were two people. It was Howard Ratzina and Norman Barker, and they wrote an article about Roman Wisniak. I didn't know nothing about Wisniak until that day. And Wisniak was a photographer and great microscopist. And this article was very inspirational for me because I found out that I'm using the same techniques that Wisniak used 70 years ago. So he used to take photos of the sediment of perfume in polarized light and photograph the crystals of these sediments. And I said to myself, oh, that will be great to try it. I have never crystallized perfume. And I thought that it will be very easy, but I was very wrong. It was super difficult. I tried for a month. I couldn't crystallize anything. The office started to smell like shitty bar, and the smell was so strong that I decided to stop. And yeah, I forgot about this. But last year, a very good friend of mine, he had an accident in a motorcycle. So I paid him a visit, and that day he told me that the day of the accident, he was carrying in his backpack a bottle of perfume. This bottle didn't break, but it got a crack. And yeah, it would be a good idea to put it in a new bottle because this bottle will break eventually. So my friend asked me if I can help him to find a new bottle. And I said, yeah, I may have something in the office that may work. And I took the bottle with me to my truck. And when I closed the door of the truck, the thing exploded in my hand and it dropped pretty much everything inside. And the smell was, within minutes, the smell was so strong that it was very difficult to read, even with all windows open. And then I got all this flashback from Vishniak. So I said, okay, let's try it again, but let's try something different. So instead of trying to crystallize the sediments, I used the perfume to dissolve hydroquinone. And I choose hydroquinone just because somehow it's related with the cosmetic industry. But I decided to make changes. So instead of using transmitted polarized light, I decided to use DAC, which is a variation of polarization, but now in reflected light. And I got these views. I make this video using my cell phone. And here I was not interested in understanding the chemical reaction between the hydroquinone and the perfume. I was not interested in understanding the shapes of the crystals. I only want to get the colors and the contrast I like it at that moment. And I will say that this is an example of art driven by science. So in order to get this color, you need to have the basic understanding of microscopy, of polarization, and the good thing is not that difficult. Everyone can learn how to do this. But yeah, this will be an example of art driven by science. On the other hand, I have this video of a tardigrade observed with the same technique, DAC in reflected light. And yeah, this little one is not swimming in purple water and is not full color. I mean, it was swimming in clear water, and the little guy was almost transparent, a little bit brown, but almost transparent. And yeah, all these colors we are seeing here are interference colors and depend on the angle of polarization, but mainly on the differences of mechanical stress that are present in the fluid surrounding the tardigrade, but also in the fluids inside the tardi. So here we can use the differences of mechanical stress as a contrast media. And this was inspired and somehow by the crystallization of hydroquinone and perfume. So this will be an example of science inspired by art. Now, there are photos, images that grab our attention and we just cannot stop looking at them. And I don't know what they have, but I get that some photos spark emotion on us. And since we create images also with microscope, we can spark emotion also with the images that we take with the microscopes. And scientists, I think that scientists have to take advantage of the emotional impact of your micrographs because images have a significant impact on science communication. And to prove this, I have a couple of stories. One is in 2023, a friend of mine, she has a coffee shop in Saltillo. Saltillo is a city in North Mexico. And this coffee shop's name is Flor y Canela, is flower and cinnamon. And she has a wall in this coffee shop that is dedicated for art exhibitions, usually local artists. But she gave me the opportunity to exhibit it there. And we put together an exhibition of flowers taken under the microscope. We named this exhibition Flores y Florescencia, like flowers in fluorescence, trying to make it a match with the name of the coffee shop. And we put together these 6 images of plants and flowers observed in fluorescence under the microscope, most of them using autofluorescence of the samples. Here you can see the wall in the coffee shop. And like a couple of days later after the opening, a local newspaper released an article about the exhibition. And then you can see here the El Heraldo de Saltillo was the newspaper. And then a couple of weeks later, my friend called me and she told me, you need to teach me about fluorescence because many people are coming to the coffee shop to see your photos, and they are asking about them. And in Saltillo, it is located a research center for applied chemistry, the SICA. So scientists were visiting the cafe, and they were asking the waitress and the people in the bartenders, okay, why the color, how was the sample prepared, and nobody couldn't explain to them. And we have labels, like very small explanation of what you are seeing in this picture, in these photos, but was not enough. So people wanted to know more, and not only the scientists, but also the regular people, the people who is not somehow related to science. They were also asking about the colors. And so my friend told me, you have to teach me, because I have to tell them something and not just read the caption in the labels. And that happened only because people find these images attractive. Another example, in March this year in Ciudad Juarez, the city where I live, there was a science festival. The festival was Ciencia Arte, kind of making a mixed word of science, art, and technology. It was held in a local science museum for kids. And I was invited with very short notice by some friends from the local chemistry society. And they invited me a Saturday, 3 p.m., to make an exhibition next Sunday in the morning. And I told them, I have nothing prepared, but let me see what I can find. So I called some friends that I have some pictures that I took with the microscope, and I called them, hey, do you remember the pictures you have? May I borrow it for a couple of days? And say yes. And you can see them here, very poorly and messy installed. Any art curator will have a heart attack if they see how would they exhibit it. And also I got my stereo microscope that I use when I have to do maintenance on microscopes. And I adapted some polarizer filters. I attached a circular rotating stage. And also I put my cell phone on the eyepieces to connect it to a projector. And as you can see here, it's a very messy setup. Like the projector was very small, with not powerful enough to project correctly. And yeah, but it was what it was. So with very short notice, and I also prepared some saturated solution of amino acids, so dissolved in water. And I took this photo at 9 a.m. in the morning, just before the opening of the museum, and was the only image that the photo that I took, because the rest of the day was very busy. And that was because all the people that came by in front of the stand, they looked at this picture, and the people asked, can we see that that picture in the microscope? And I told them, not exactly that one, but we can make something similar. So we crystallize live on the fly some crystals of the amino acids, so the people can see through the cell phone and to the projection how the crystal grow, and they observe all the colors in polarized light. And then the next question came from kids, from their parents, from teenagers, from grandparents, from the janitors of the museum, from people from other stands. And this question was, what are amino acids? And at that moment, you realize that I have you. Now you are going to learn everything about amino acids. And that was wonderful, because we are usually trying to push the information to people that, hey, this is what I'm doing. But in this case, the attendees are pulling that information. They wanted to know more. And it is, especially with teenagers, it's very difficult to grab their attention. And so a couple of stands to our left, there was another stand with neuroscientists. So they came to our stand to chat with the kids and explain about the amino acids and what are they important for the brain connection, the connection of the neurons. And also the kids were able to take the slide with them to home because we crystallize it. We make this crystal right there, and they were surprised when they took the crystal, the slide out of the microscope, and they say, okay, but this is colorless, transparent. Why those colors? And that's exactly what we want. Okay, these are interference colors and depend on the angle of polarization. And geologists use these colors to identify minerals. And it happened that a couple of stands to the other side, there was another stand with geologists. And then they came to our stand to explain the kids and to explain the people about the birefringence, and they bring rocks in thin section, and everything was a wonderful symbiosis. And all started just because people found interesting this image, not because the title of the people of the or anything. So everything started because this image. Now I want to change a little bit to a topic that I think is super important, and is the enhancing or manipulation or processing of images. And this is every day more important because now it's very difficult to identify if an image is real or if it's AI. And I will say, if we have to define at the beginning, what is the intention of an image? When I capturing an image, what is the purpose? And if the intention is 100% for artistic expression, I will say, in my opinion, that there are no limits. Do whatever you need to do in order to create that image that sparks emotion on you. I personally, if you want to use artificial intelligence, it's up to you. I personally, I don't like it, but it is up to you. There is no limit when it's about art. But if the image is going to be used for something related with science, could be science communication or to explain something in a conference, there is science involved, there should be limits, and we have to define it, and we have to define the guidelines, and that's so important. And I have this question. This is a daisy flower observer in autofluorescence, and I will ask you to put in the chat if you find this a real image or if it is a artificial intelligence generated. So I will give you a couple of seconds to put in the chat if you think this is real or AI. Let me see if I can see the chat. Yeah. And okay, well, this image is, this part of the image is real. I took it with a 5x objective, and it's a focus stacked. So at first I get a C stack of this sample in a single channel, or red, green, and blue in a single channel. I used this filter set, and then I did a deconvolution just for fun, not really needed, but I wanted to play with the software. Then I extended, make the extended focus image. Then I split the channels in red, green, and blue. Then I remerged the channels just to be able to adjust and apply the next step of the processing for each channel separately. But when I took this, then I found it, hell, what I was thinking, why I didn't move the stage a little bit to the right and capture a little bit more of the sample. So, and it was not possible to retake the photo. So the sample was damaged after this, and I cannot take it again. So I took it to Photoshop, and then I extended the area of the image. So it got a white background, and then I just click it, the generative fill tool, no prompt, nothing, just extended and click one button, and I got this. And I was impressed, but at the same time scared, because for me it was pretty difficult to tell, okay, I have to like be very specific to checking, okay, this is real, this is not. And yeah, this is beautiful, but also we can find some not real images in science that will mislead or misinform or create fake information that at the end will not contribute to science. And if you are wondering how this look like, this is the extended focus image without any processing, so without the convolution and without the adjustment and the brightness and contrast. But well, this is scary, but we don't have to be afraid, or we don't have to make or to think that highly processed images are bad or wrong. And to explain that, I have this other example. This came from the James Webb Spatial Telescope. It's beautiful image. I think this is one of these great images that provide information and also look well. But many people think that you can look to a screen or to eyepieces and find this beautiful scenario. But the thing is, you cannot see at this because this image came from infrared. So they made it a multi-channel infrared images where someone decided, okay, for this channel, we are going to see it in blue, and this channel, we are going to see it in green, red, cyan, orange, just the same way we do in fluorescent microscopy or in multiplex microscopy. And also, for example, these A peaks in the stars, well, is not, well, they are produced because the diffraction of light at the edges of the mirrors in the telescope. So if you change the mirror array, you will have different shape in this star. So this image is not something that you can see, but and it's highly processed. But I will say that the data is real, so you can use information taken from this. So we don't have to be afraid of the highly processed images. We only need to be or get well-defined guidelines. And this is my opinion that all we have to define a guideline, but any guideline should include at least these 4 points: that all processing steps should be repeatable and reproducible. So if I repeat the processing step, I will get the same results. Or if anyone, anywhere, and anytime follow the processing step, should get the same results. Also, all processing steps should be applied to the entire image. So the use of this brush tool in the Photoshop should not be used for processing images for science. We have to also keep the originals and all processing steps in order to be available and to be declared, especially for journals, for the people, just in the same way like NASA does, like, okay, we did all this processing. Now, very important, we have to put at the same level the data we want to get from the images and also the aesthetics of the image at the same level. So we have to put the same science and art. The recommendation or the best practice is that before bringing a sample to the microscope, we have to define, okay, what information I'm looking for, what answer I'm trying to get from the microscope. And because from that will depend how will you prepare your sample or what microscopy technique you will use. But you have to also consider, okay, I will get this information and how I will make that image attractive to people. So you can easily communicate it. And just to close, some recommendations. If you want to get great images, those ones that provide you information, but also are eye-catching, you need to learn the basics of microscopy. And please read the microscope manual. There is a lot of scientists that rely their work on the use of high-end microscope or high-end equipment, and they don't understand how it works, and they don't read the user manual. So you have to learn it. The good thing is that if you join BINA and GBI and LAVI, you will have access to a bunch of resources, also have access to a wonderful network of community that you will always find someone that will help you to solve a problem in microscopy. So it's a great opportunity, and it is for free to join this community. Also, I will recommend to network with people outside your professional circle. Yeah, it is very comfy and easy to hang out with our colleagues, the people who understand the science or the work you are doing, or the people who understand the nerd jokes. But you can be surprised when you look how other areas are using the microscopes. For example, the idea of using the DIC reflected light, the one that I use with tardigrade, came from material science. Material scientists use that technique to contrast stress. And also geologists, they use fluorescence. And the filter set that I use with the daisy flower is the same filter that geologists use to evaluate the thermal maturity of materials in coal, so they can determine how much energy can they take from the coal. So I will invite you to check out how other people in other areas are using the microscopes. And finally, we need to teach our scientists to communicate science. And especially if you are microscopists, we need to teach our microscopists to create these attractive images. That should be part of the training, because if the science is not communicated, it is a waste of resources. So we have to tell the world about science. And when I was in college, I had a class, the name was Public Speaking and Academic Writing. And the teacher was this grumpy old lady, very sarcastic. And she used to tell us, 80% of your professional success will depend on how well you communicate. So you may be the best engineer, you may be the best scientist, but if you don't communicate well, it is nothing. So we have to learn to improve our communication skills, because it's kind of sad when I see presentation of microscopists, especially, that they produce beautiful images and their presentation have a small image in the corner, a bunch of text, and bunch of graphs. Nobody reads the text in your presentations, especially those ones that are in the back of the room. So because if you put a lot of text, you have to make the size of the letter smaller, and it will be very difficult to read. Also, at least 10% of the population are dyslexic like me, so will have problem reading. So if the people is not going to read the text in your presentation, take it away. Also with the graphs, the graph, if you cannot read the axis of the graphs, then are meaningless or are just lines and bars. So take it away also and make the image bigger, and that will help to improve the quality and the share of information in your presentations. And well, that's it. I hope you find this useful and entertaining, and I will be very happy to answer your questions. And if I'm not able to answer your question today, these are my contact data. You can send me an email and I will be very happy to answer it. And also this QR code has all my contact data you wanted. And yeah, you're very welcome to follow, especially Química_Tech or my LinkedIn, where I post most of the images I take with microscopes. Thank you so much.
Well, thank you. That was awesome. That was one of the most interesting talks that I've attended in forever.
Thank you so much.
Maybe ever. Wow. Okay. Well, I would say leave that up for another 30 seconds to make sure people can get the information down. Actually, I'm going to take a picture of it myself. But we want to know if people have got questions for Manuel. So maybe after they've taken this down, we should stop sharing his screen, and then people can see each other better and turn on their cameras if they want to ask a question. So is there anybody at the moment? I'm sorry, I'm too busy looking at the movies to see whether there are any questions coming up. Thank you.
Did you process your samples from Montreal, and what did you take? Will you tell us about them?
I just put the maple syrup to crystallize.
Okay.
And it will take like a couple of days more, and we will have some crystals from the maple. And I'm still having here the hoping the tardigrades. Haven't had chance to put it in a petri dish, but hopefully in the next few days I will have it.
Do a comparison of tardigrades from Canada and tardigrades from Mexico, maybe?
Yeah. Well, the ones that I have from Mexico, they are already die in my microscope. Sorry for that. But at least I have the pictures, and so we can have some comparisons. And some.
That's fantastic. I see Chris has got his hand up. Chris, do you want to ask your question?
Yeah, tis a question. I mean, apart from echoing all of the, I mean, here at the National Lab, we have a number of contacts with communities that aren't so traditional, but I'm not here to talk about those. But Manuel, you were partnering with a lot of different, say, organizations, a lot of different foundations, a lot of people that would be interested in these cafes and foundations and things like that. How do you reach out? Do they come to you? How much do you reach out to them? How do you make these contacts? Because they are cross-disciplinary, you know, having a,
Yep.
Is it just coming through spontaneous conversations with cafe owners? Do you walk in and see that they've already got art on the walls and say, well, look, I've got some great images. How would you be interested in this? How do these connections arise? Because they are quite diverse. They range from schools to local businesses to all sorts of different places. So could you talk a bit about that? Because I'm sure a lot of us are interested in exploring this artistic side, but aren't necessarily spontaneously sort of generating these sorts of contacts.
Yeah, that's well, it happened in a very funny way for me. In my company, we sell microscope, but we don't like to put like okay, this is the microscope. We usually try to understand what the user need to do, and then we build a configuration, and we tell the customers, okay, if you buy this configuration, you will be able to get this kind of pictures. And in that way, I ended up with like 8 terabytes of photographs that I was keeping it to myself. But a friend told me, oh, why you don't put it in Instagram? And I started to posting them. And then all the contacts, in my case, came from the Instagram. And also, I learned that, and I recommend to everybody to take part in imaging contests, because that will help you to improve the quality of the image in order to make a match with the public. And also, in my case, most of the contact from these organizations came from Instagram and for taking part in imaging contests. Sometimes I participate like in 8 or 10 contests a year. I don't win all of them, but at least the users, I have the chance that the users know me. And sometimes they write to me, okay, can we have a talk? Can we have a collaboration? And also companies, they say, oh, okay, I will be very happy if you can test my filters. And maybe you can like a influencer, but in very specific way, like, okay, make an evaluation of my filter, make an evaluation of my fluorescent lamp, and about this microscope. And in my case, all started from Instagram and LinkedIn, and also from taking part of imaging contests or Microscopy Society of America, the Royal Microscopy Society. And there are a lot of imaging contests that are focused on science and art at the same time. But there are also that are totally focused on art, and I send images that I take with microscope, and that also give you, or give me in my case, exposure and connection to people.
Yeah, thank you. I think it kind of creates a circle, doesn't it? If you win an imaging competition, then the local press are kind of interested, and then they can make an article about that, and then that article goes out and people see that, and like I say, local businesses get interested. So it can create it's important to make that cascade of sort of information flow. So and that brings people to your Instagram, and you make connections through that way. That's certainly something that we've found.
Yeah. Also, for example, one of the images that I like it a lot is that one that I took from the eyes of the scorpions. It got the Royal Society Award, and it came in a lot of Instagram people, and that give a lot of exposure. And yeah, in my case, that is the way it works better.
We've certainly been reaching out as well to, we've certainly been reaching out to photographic academies, people that are already interested in images. So for instance, if you buy, I don't know if it works like this all around the world, but if you buy a Canon camera, like an SLR or whatever, then I think you get a voucher to participate. They organize workshops, and
Yep.
some of them are to pay. Anyone can join, they can pay. But I think if you get a Canon camera, you get a voucher to join at least one of these basics. So we had contact with a photographer who's one of the tutors in these Canon Academy workshops, and they introduced a sort of a scientific macro module into their workshops, because again, they're trying to sell a product. They want things that are attractive and differentiate themselves from all the other scientific workshops. So we have an interesting set of instruments and an interesting set of techniques that we can bring to these sorts of scenarios that can create even a commercial connection. So yeah, it kind of happens a little bit spontaneously at first. It's a little bit serendipitous. But again, getting stuff out there on Instagram, participating in the competitions creates this snowball effect of interest that is something that we've certainly exploited. Anyway, Alison, please.
You're making me think I need to join Instagram, which is another thing I haven't done yet. But no, my question was, I was fascinated when you made the comment, which was absolutely correct, that you've got to be communicating the science well along with showing a nice image. So I think a lot of the time people show a nice image, but then, and I'm certainly guilty of this, the image caption may not be gripping enough. Yeah. So I'm just wondering, how much work do you put into thinking about the image captions? Have you found of any kind of sources of advice that have helped you in creating a catchy but scientific caption?
Actually, I don't know. I just try to write as less as possible, but sometimes that is like too little. But I don't know how to define how is the optimal amount of description. And my guess is that it will depend on the audience. So if you are targeting to kids in a kids museum, you have to adapt it for that. If you are targeting to scientists, like in this BINA meeting, so you have to adapt your text. But yeah, it's something that very difficult to me to define. And sometimes, especially when it's for art exhibition that they want to show to art people, they always want to know about my creative process and what inspired me, and I always have problem because I don't know what this creative process is, and usually the inspiration for me is procrastination, because sometimes I have to do a lot of paperwork in the office that I hate, and then I make an excuse to go to the microscope and, oh, let's put this crystal or whatever. So but I will say that you have to adapt to depending on who is your audience.
I think we can all empathize with that one.
Yeah. I also will recommend that, especially core facilities, there should be kind of a art gallery together with the core facility. So for sure you have a lot of walls. I see court facility with tons of posters from Congress. Take out those posters and put photograph of your of the images you make there. Something that I liked in Montreal last week, there were a lot of art galleries, and there are some of them that were okay, this is a tattoo shop and also art gallery. This is a boutique and art gallery. This is a coffee shop and also art gallery. So we can do the same with the core facilities that will attract people, also sponsors. So you may get grants for making the attracting there, and you can also do this kind of, okay, if you support the initiative of this core facility and you give, like, I don't know, such amount of money for the core facility, you will get a fine art print of some of our photographs. And I think core facilities should be also a art gallery.
Yeah, I'm looking at in the chat. I see Brandy says that Brandeis is doing this already, which is great. And I will confess, I have not done it enough, because I think things like the cost and the time, honestly, it's just it always just falls behind in priority lists, and it shouldn't. You're right. It's really, really important. But when you said that you might get funding to do this, you know, what do you have recommendations for, like, who you would approach for that?
Once I heard the story from some professor from Rochester, New York, and they ran like a funding dinner, and they broke a small microscope. And they were crystallizing the drinks from the sponsors, and so they got this kind of and they gave these ties or with prints of crystals, and that may like a good idea. I have never tried in such a way, but it could work.
So I just have to share with you now, I'm sorry, I'm taking over, but just on that theme, I was approached by somebody who came to New York for a fundraising event for this organization who digs wells in Africa to get people fresh water. And she had some of the water from the river that people were drinking. And she said, was there any way that I could take a picture of this so she could show it in the fundraising event? So I actually took a movie of it, and I upped the contrast amazingly until you could see all these disgusting bacteria and things running around in the back of the movie. And then she projected this at full size behind everybody eating. And apparently they raised more in that event because people could see what they were dealing with, you know, the filthy water that people were drinking.
Yeah. Also,
that's fun.
Last year, I was invited by Diego Delgado, you know, maybe, you know, in CICESE. He organized like a science talk in a bar in his city in Ensenada, Mexico. So we gave like a small talk about microscopy. Then we crystallized things in the bar with the drinks from the bar, and then a band was playing at the same time. We saw in a projection how the crystal were growing, and yeah, that will be like also excellent idea to fundraising activity.
That's nice. I have an insect running around in my glasses. That's why I keep saying that. Has anyone? Oh, Chris has got another question.
Yeah, it's a bit more technical this time. So you mentioned so there's often a very big difference, obviously, between scientific images and artistic images. Scientific images are usually, you know, you're trying to take them as fast as possible. That might mean you have few pixels. They might not be quite as, shall we say, aesthetically pleasing. So what were you using to capture your images? I think you mentioned your mobile phone, but how was that mounted? That wasn't just sticking a mobile phone on the eyepiece, surely. You know? So how are you capturing these images with a much higher, say, pixel count than a scientific image would necessarily have?
Well, I have 3 cameras. Well, 4. One, for example, my cell phone, and I have an adapter. This is a lab cam adapter. I don't have it here, but with that, it's very easy to put it in the eyepieces, and you forget about this moving around and get nice images. The thing with that is that you cannot rely on measurements. So because you can make this digital zoom, so all the measurements are not possible. Well, you can measure, but will not be good. And I also have a YouTuber camera. It works pretty well, but also the adapter is a cheap one. It's the camera that I was using in Montreal to taking photos, and this adapter has a lot of spherical aberration, so you can have nice images, but with blurry edges. And the third one, I have a Axiocam from Zeiss, 2 megapixels, and that's the one that I use for technical stuff. That when I have to measure things, when I have to keep all the metadata in place in order to have a track of all the processings. That the one that I use. And I also have another one from Image Source company. That's a German company. And that one that I use for like general stuff, and when I have to take fast photos.
Yeah,
Super interesting.
Might be interesting to have some details of these adapters that you're using. So I don't know if that can be arranged somehow, because it's not the same. It's not the same as using a scientific grade camera. That has very different purposes to an SLR or mounting a Canon or whatever Sony camera. Microscope.
Yeah, for example, the scientific camera that I use when I try to go to print, well, you have very good resolution, well, acceptable resolution, but you cannot print bigger images. So you have the bigger that I was able to print that I liked it was 40 centimeters by 50 centimeters. And that's it. And usually artists want to print like big. For that, I use the Sony camera, even if it have this aberration at the end.
Can I ask you a question?
Yeah, sure.
Hi, Manuel. Wonderful talk. Thank you.
Thank you.
We know each other from Instagram, actually.
Ah, thank you.
Yeah. So have you ever done time lapse?
Yeah.
Over a course of, I don't know, days?
Well, not days.
Or yeah,
but,
like how long?
Yeah, the longest I tried is like 8 hours.
And you just do it a setting on your camera?
Yeah, I put it like put it like an automation, like take a photo every 2 minutes or so. And I tried the one that I tried was with to capture the process of crystallization of monosodium glutamate, but somehow the experiment failed. So from the 8 hours, only the first 30 minutes were okay, and
oh.
But in live things, yeah, only for process of crystallization is that the one that I have tried.
That makes sense. And with the amino acids that you use, like how do you get them and how do you know what's safe to handle? And do you ever do like really lab safety kind of precautions with the substances that you photograph?
No,
how many of them are make good for a cocktail hour too?
Yes, some of the I will say that you have to check safety first, but as mentioned before, I'm pretty messy, and I usually check the safety issues after something explodes. And actually, I have the story like 4 years ago, we had a very beautiful green fluorescent rock in the lab, and then it turned out that it was uranium.
Oh my God.
So probably the lab's contaminated already, but yeah, I recommend that to check if there are some chemicals that you should not mix before put it to the microscope.
Isn't there like a website for that? I used to know what it is because I was doing liquid crystallizations, and sometimes or different chemicals, to be careful. And I can't remember the name of it, but
the website. No, I don't have it. But
it sounds like you maybe even.
No,
I think maybe we need to edit the end off this movie where Vad admits to having radioactive light.
Yes.
Yeah, cut that part. You were just kidding. And what about amino acids? Where do you get them?
I get from the name of the store is this GNC. You know, where you can buy this, and you can get like free samples. Like you get like, I don't know, 200, like 20 grams or something like that, just like the sample they give away. And with that 20 grams, you can make like thousands of slides. Yeah.
So wait, that's the vitamin company.
Yep.
You're saying GNC. Oh,
GNC.
wow.
And
Amazing.
also sometimes I use like from the regular drugstore, where you can buy this, for example, caries remover or vitamins.
And it's
like
liquid or it's solid tablet?
Usually I got it in solid, and then I make tries like dissolving in water, dissolving in alcohol, dissolving in tequila or mezcal or any alcohol drink. Sometimes I use acetone to dissolve, and so far my favorite is bacanora. It's kind of a drink made like tequila but stronger, and that's, I don't know what's happening in this chemical reaction, but the crystal that I get from dissolving chemicals and amino acids in this bacanora are my favorites.
That's so interesting. I feel like I've seen some of those images.
Yeah.
That you talked about.
I have to say, I love that you're continuing this. That, you know, the work that Mike Davidson set up his whole lab on, taking pictures of crystals of cocktails. So it's great to see the theme continuing. It is 2:05, so